Hello students, this is the teacher Walter. I'm back again for the second lesson on complex numbers, senior 6. I again remind you that this senior 6 is from the curriculum of Rwanda, given by Rwanda Education Board in the new curriculum, which is called competence-based curriculum. Last time we talked about complex numbers, which was a set discovered when they have seen that the normal used sets were not sufficient. These were including the set of natural numbers, they were including the set of integers, they were including the set of rational numbers, and they were including, among others, the set of real numbers. So here we have seen last time that mathematicians have been unable to solve some equations, and we have seen the equations well, z, which is equal to, the equation was x squared plus 4, which is equal to 0, whereby if we take 4 on the other side of the negative sign, we was to get x squared, which is equal to negative 4, and we have seen that x will now be equal to plus or minus square roots of negative 4. So to solve this, it was impossible in the set of real numbers. Why was it impossible? It was impossible because it is not possible to find the square roots of a negative number. We normally use the positive numbers to find the square roots. So for this one now, we were stuck here. So last time I told you that mathematicians have tried to discover a new set which was called the set of complex numbers. And why were they calling it complex numbers? So it were called complex numbers because we have seen that every number from that set was to have a form z, which is equal to a plus bi. If you remember very well, if you have watched the first video, it was showing you that a is the real part of z and b is the imaginary part of z. And now, because it have two parts, that's why they were calling it the set of complex numbers. So within this number z, we have seen that a, b have to be real numbers. But what about now this small I? This I must be, I squared must be equal to negative 1. I squared must be equal to negative 1 so that we can be able to work with these complex numbers. I squared is always equal to negative 1, and I itself will be equal to square roots of negative 1. Whenever we should be having now negative 1, we should be putting I squared. And wherever we shall have square root of negative 1, we shall have I. This will be working with the complex numbers. Now, after mathematicians have now discovered this, they have been able to solve the following equations, as well as other equations that looks like that. So we shall see that from the step where we were last time, we were stuck at the level where x was equal to plus or minus square roots of negative 4. Now, after seeing that square roots of negative 1 equals to I, or we can even say I squared equals to negative 1, it will both of them will work. So we shall see that x here equals to plus or minus square roots of negative 1 times square roots of 4. You know that we can remove the numbers in the square roots if there are products. So here, because we have this, they have immediately said now that x will be equal to plus or minus, because we know that square roots of negative 1, we have seen that is equal to I, so we shall have now I square roots of 4. And we normally know that square root of 4 equals to 2. So we shall have that x will be equal to plus or minus I times 2. And this is what we write as x equals to plus or minus 2i. You know, multiplication is commutative. So you can either start with 2 or start with I, there is no problem. So here, what do you observe now? There is now a solution. But this solution we get, it's not in the set of real numbers. It is rather in the set of complex numbers. So complex numbers have come to solve many problems. Among others, they include to be able to find the square roots of a negative number, as we have been able to find it here. And it have come also to find solutions for some equations that were impossible in the set of real numbers. I think everybody have seen how we have found the solution, and have been able to find the solution for x, which will be plus or minus 2i, which means that the set of solution, our set of solution now will be negative 2i and 2i. That's why we have plus or minus. This is our set of solution for this previous equation, which was impossible in the previous work because we were not able to find the square roots of a negative number. Now, we are coming back to I. Coming back to I, we have seen that every complex number z that belong in the set of complex number have to be of the form z, which is equal to a plus bi. Actually, this form is called the algebraic form. It's called the algebraic form of a complex number. This is the algebraic form of a complex number. Now, we have seen that the first part is called the real part. The second part is called the imaginary part because it is with the imaginary unit. I is called the imaginary unit. It's called the imaginary unit. And we shall see, and it is the first letter. It is the first letter. It is the first letter of the word. Imaginary. It is the first letter of the word imaginary, and that's why it is called. This part is called the imaginary part. So, I'm here going to take you through the properties of this I. Remembering that this is the algebraic form of a complex number, we are now going to talk about properties of I. Okay, within the properties of I, we shall also talk about the powers of I. So, I, we have different powers. If we go deeply, I power 1, this will always be equal to 1 because you know that every number power 1 is 1. So we shall have I power 2. I power 2 will also be negative 1 because we have seen it before that mathematicians have supposed that I squared have to be equal to negative 1. Now, what about I cubed? I cubed will be equal to, if we try to split it, it will be equal to I squared times I. And this will take it to be what? Because we know that I power 2 equals to negative 1. So we multiply it again to I, and we finally see that it is equal to negative I. Which means that I cubed will be split into I squared times I, and we get negative 1 from I squared times I, and this will be negative I. What about now I power 4? If we go for I power 4, we shall have this. We shall split it also into two things. It can be I power 2 times again I power 2. And this will be what? I squared equals to negative 1. We all know, we have seen it so far. And again, times I squared, which is also equal to negative 1. So, if we multiply both the two, we shall see that negative 1 times negative 1, this will give us 1. Because we all know that negative times negative gives us positive. So we get -1. We can even go on with other different powers. Let us try like I power 5. And this will be, if we try with I power 5, this will be I power 4, for example, times I. And we have already seen I power 4, which is equal to 1. This will be, of course, equal to 1 times I, and this is I. What do you observe? You will observe that after reaching from 1 to 4, there were different things. Here we have seen I, here we have -1, we have I, we have here 1. And here, after reaching to 5, starting from 5, of course going beyond, you will see that we have seen I, that we have already seen here as I power 1, which means that we are coming back to these 4 first values, either I, -1, I, and 1. So what does it mean? We shall make now a general formula which will help us to know how we can find these powers, whether we are around 4 or whether we are far from 4. It will show us how we can do it. Let us go through this. We are still talking about the powers of I and its properties. So if you can see the work we have done so far, so we can see now the power of I. We shall see that always it can work within the powers, the multiples of 4. So if we have I power 4k, this will be equal to 1. If we have I power 4k, this will be equal to 1. A good example is where we have I power 4. We have seen that this is equal to 1. This means that k was 1. So here k can be, so let me say, here, let it here, k must be equal to 0, 1, 2, or 3, etc. We can have different values of k. So if k equals to 1, we shall have I power 4, and this will be equal to 1. We can also have I power 4k plus 1. We are working with the multiples of 4. So if you divide the number by 4 and the remainder is 1, we have an example. If k, for example, here equals to 0, we shall have I power 1, and this will be equal to I. You can see whenever we have 4k plus 1, it will be equal to I. So we go on. We can also have it as 4 power k plus 2. A good example, we can say, if k equals to 0, we shall immediately get I power 2. If k equals to 0, we shall have this example, I power 2, which is equal to -1, and which means that whenever we have I power 4k plus 2, this will be equal to -1. So wherever we have now I power 4k plus 3, this will be equal to what? A good example is that you can set again k be 0 always. If k becomes 0, we shall have I power 3, and this will be I power 3, which is the good example we have here, which is -I. This will be now -I. So wherever we have any number, I power any number, we can now bring it to the factors of 4. We divide by 4. If the remainder is 0, we shall have 1. If the remainder is 1, we shall have I. If the remainder is 2, we shall have -I. If the remainder is 3, we shall have -I. So always we remember that k should be 0, 1, 2, 3, etc. So let us have some other examples having like a big number. So if I take you through this given example, if I am to find the simplest form of I power, for example, let me say 10. If I have 10 now, what should I do? I have to make it a multiple of 4. Here, what do? I take now 10 and I divide it by 4. 10 divided by 4, I will put there 2. 2 times 4, I will get 8. And if I subtract, I have to get 2. Which means that I cannot go on dividing because 2 is smaller than 4. So I stop by there. This is the remainder. this is the remainder, and now this is the quotient, this is the divisor. We shall see now the remainder is 2. If the remainder is 2, we can write the number as I power 4 times 2 here, which is 8, plus then the remainder, which is 2. And then we have the form which is exactly this one, which is 4k plus 2, which gives me -1. And I immediately show that it is -1. So I can give you another example, number 2. If we have like I power 30, for example, 31. If I have this, what do? We take again 31 and we divide by 4. 31 divided by 4, we are going to put there what? Think about it. We cannot put 4, we cannot put 1 because this is smaller than 4. So we better see which number we can put there. And then we shall see that we shall put there 7, and we get what? 28. If we subtract, we shall just find here 2. This is 11. 11 minus 8, we shall have 3. The remainder is 3. And you can see we can write now it as I power 4 times 7 plus 3. Which means that the remainder is 3. If the remainder is 3, we are having exactly this case. So which means that we shall have -I. So whenever they give you an exercise to do with this, they tell you to simplify. You have first of all to divide by 4, and then you get the remainder. If the remainder is 0, you have the first case. If the remainder is 1, you have I. If the remainder is 2, we have -1. If the remainder is 3, we have -I. So we can have here a lot of exercise that we try home, and which will help you to know whether you have understood how to simplify the powers of I. So here I will try the following exercise for your evaluation. If you want to evaluate yourself to see whether you have understood what we have learned, you will try this. The first one is that you have to find the value of the following. Number A, you will find I power 1213, and I have to propose you the solution. If you get this solution, it will be very right. I will give you number B. You will try this. I power 2244, and then if you try this and you get the answer is 1, will be very right. Number C, you will try I power 46787, and if you try this and get an answer which is -I, will be also very right. If you now try number D, and it is the last one, you have I power 182, and if you try to do it, the best answer should be here -1. So try this as you are alone. Do demonstration, divide by 4, and if you see the remainders as I have shown it, you will now get the right answers which are here, and you will know whether you have succeeded. Thank you very much. I invite you for the next lesson, which will be lesson 3 on the complex numbers. And for details, notes, evaluation exercises, and all other works, you can visit our website www.ubumenyi.net, or you can go to our TV channel ikaram.tv, and there we find all the videos that we have worked about these things and all what we should do. Thank you very much. See you next.